This first section on triangles is pretty easy. To start off, we're going to define a triangle. I'm sure you guys all know what a triangle is, but first we define a polygon. So a polygon is a plane with at least 3 straight sides and angles. So like a circle would not be a polygon. Polygons are made of straight like segments. A triangle is a polygon with 3 sides, in case you didn't know it. Here are the parts of a triangle. Triangle has sides, vertices, and angles. So if I asked you to name the sides of a triangle, they're segments. So AB, AC, and BC. And so you would list them with capital letters and the bar on top. So those are the sides of the triangle. If I asked you to identify the vertices, it's just the points. So points A, B, and C. So where the sides meet, these are the corners, these are the vertices. And then the angles are also where the vertices are. So the angles would be angle A, angle B, and angle C. Now I can call these angles A, B, and C with just one letter. I can name them with one letter because there's no other angle there with A as its vertex. There's no other angle with B as its vertex. There's no other angle as C as its vertex. It's when there's like other angles, like if I like drew a line here, I couldn't call this angle C. You can also name them with 3 letters, remember too, like A could also be BAC or CAB. So those are the parts of a triangle. Now we're going to talk about how we can classify them. So you can classify triangles by their angles, the measures of their angles, and their sides, how many congruent sides it has. Okay, so to classify by angles, an acute triangle is when all 3 angles are less than 90. Also too, I am going to scan this in when I'm done filling it out, and I will add it to today's classroom post so you have the filled in version of this too to use, as always. Okay, an obtuse triangle is when it has one angle greater than 90. Because remember, an obtuse angle is an angle that's bigger than 90. So when you have an obtuse triangle, you'll have the one angle that's bigger than 90, and then the other 2 angles are acute. They're less than 90 because you can't have more than one obtuse angle in a triangle. So it's only one. A right triangle we've talked about, it's when one angle is 90 degrees. When we did Pythagorean theorem, that was right triangles. And then an equiangular triangle, it's when all angles are congruent. And they're actually all 60 degrees. If you remember, we talked about earlier in the year that triangles add to 180. So if you have 3 angles in the triangle and they're all congruent, 180 divided by 3 is 60. So if you want to add that in, you could add that in. Okay, so that's classifying triangles by their angles. We can also classify a triangle by how many congruent sides it has. A scalene triangle is when no sides are equal. Has no congruent sides, so they're all different. Equilateral is when all sides are congruent. And an isosceles triangle is when at least 2. Mostly it's just 2. Technically, an equilateral is a type of isosceles triangle. So that's, oops, I didn't put least. It's at least 2 congruent sides. So technically, if you had an equilateral triangle, that would also be considered a type of isosceles triangle. But usually when you have all 3 sides, you just say it's equilateral. You don't say it's also isosceles. And when it's 2 sides, you say it's isosceles. Okay. So that's how we can classify by sides. So in the practice today, your practice is a quiz. It'll say like classify by angles or classify by sides, or some of them classify by angles and sides, which I'm going to do down here. So the first one, let me zoom in a little bit. This first one, notice we have a 100-degree angle, a 40-degree angle, and a 40-degree angle. So this would be an obtuse triangle based on the angles. And then by sides, notice they didn't tell us anything about the sides, but we can determine how many sides are congruent based on how many angles are congruent. So see how there's these 2 40-degree angles? If 2 angles are the same, that means two sides are the same. So this is an obtuse isosceles triangle. And so you don't even have to know the lengths of the sides. If you just look at the angles, you can determine if the sides will be equal. Okay, so how about letter B? Letter B, we have 85, 30, and 65. Can we classify first by angles? What would this one be by angles? Write it in the chat, or you can unmute yourself if you're comfortable. So what would B be by angles? So this one wouldn't be obtuse. Obtuse is if one angle is bigger than 90, Ella. See how they're all less than 90? Acute, yeah, so it would be acute instead because all three angles are less than 90. Okay, and then notice now that all three angles are different. So that means that all three sides would be different, which would make it scalene. So this is an acute scalene triangle because all three angles are less than 90 and all three angles are different, which makes all three sides different. Okay, letter C, notice we have this 90-degree angle here. So what kind of triangle is this by angles? Okay, good, Dylan, right. How about by sides? Does it have any congruent sides? What kind would it be by sides? Do we need the reminder of this? Let me zoom out. If no sides are the same, good, scalene, awesome. So that's a right scalene triangle. Okay, so that's like the main part of this section is just classifying. See how easy it is? I wasn't lying. Oh, I forgot we have more classifying. Just kidding. Another example. So for this one, I'm going to switch to my pencil. Same idea. We're just going to classify by markings now. So the first one is triangle ABD. So, okay, also, this is how you name a triangle. I should mention that. Triangle symbol and then the capital letters in any order. So ABD would be this one here. What would we think this one is by sides, I guess? We'll go with sides first. If all three sides are the same. So Jake says acute equilateral. So yes, equilateral, and it is technically acute, Jake. So you're right, it is acute equilateral. However, there's another angle classification that's a little bit better than acute for this one. If all three sides are the same, all three angles would also be the same. So this would be equilateral and equiangular would be the best one. So anytime all three sides are the same, all three angles are the same too. So it's acute and, I mean, it is acute, but the more specific classification would be that it's equiangular. Okay, next one is EBD. EBD is this one, this little triangle. What do we think about that one? Do by sides first. What do we think by, okay, it is obtuse, never mind, it's obtuse, sure. Okay, how about by sides now, EBD? Do we need the reminder of this? So two sides were the same, so that means it's isosceles. Perfect. Okay, F is BDC. BDC. Okay, hold on, let me erase some of this. Okay, so BDC is this one. Notice this. So what do we think about BDC? Angles or sides first, doesn't matter, whatever anyone thinks about BDC. Anyone? Obtuse. Good, Michael, definitely obtuse. I know it's obtuse because this is a right angle and this goes beyond that. So like this is obviously bigger than 90. And then yeah, McKenna, isosceles. It's also isosceles. Awesome. It's isosceles because BD and DC are congruent. Okay, and then the last one is ABC. So ABC is the big triangle, like the whole thing. What do we think about that one? So ABC, the last one. It's definitely right. Oh, who said right scalene? McKenna, yeah. It's right, and it is scalene. McKenna was right. She was right about the right scalene triangle. All right, anyway, so none of the sides are the same. So this one has one tick mark. This one is double this one, and then this one, I don't know, has like weird markings. So it's right and scalene. Perfect. Okay, so that's basic classifying. The next part is on specifically isosceles triangles and some of the parts of isosceles triangles. This is where the algebra problems come in. So up here it says, just like a right triangle, the parts of an isosceles triangle have special names. Whoops, I don't need to write triangle. So the parts of an isosceles triangle have special names. So first of all, we know an isosceles triangle has two congruent sides, right? Those are called the legs. So this one and this one would be the legs. I'm actually going to label these so we can. So the legs of this isosceles triangle would be AB and AC. The vertex angle. So an isosceles triangle has a vertex angle, is this right here. So it's the angle where the legs intersect. So why this is important, this is really important, is in some of the algebra problems, it might say like, in this one, it would say angle A is the vertex angle. So that tells you which sides of the isosceles triangle are congruent. So the vertex angle is where the two legs intersect. Then there's something called the base angles, which we're not really going to talk too much about yet. There's another section, 4.6 later on in the unit that we talk about base angles, but the base angles are where the legs intersect. Whoops, I forgot to label this one. The base is the side that's opposite the vertex. So side, opposite, vertex. Sorry, I'm doing this all out of order, which is BC in this case is the base of it. And so the base angles are where the legs meet the base. So like this and this are the base angles, and the base angles of an isosceles triangle are congruent. So it's the two congruent angles where legs meet base. So in this example, it's angle B and angle Z. I forgot to put the vertex angle as angle A. I circled it, but. Okay, so those are the parts of an isosceles triangle. I'll let you finish writing it down for those who are following along. We use this to help us solve like algebra problems. Okay, so this example here, this next one says RST is an isosceles triangle. Angle R is the vertex angle. And then they give us the three sides. So it says draw and label a picture, write an equation, solve for X, find blah, blah, blah. So we need a triangle. That's isosceles. It says R is the vertex angle. So R would be here. R is the angle where the two sides, the congruent sides meet. So then S and T can go here and here. It doesn't matter where. So then if we label the rest, it says RS is X plus 7. ST is X minus 1. And RT is 3X minus 5. So they gave us all three sides of the triangle, but we really only know something about two of them, right? Do you see how we know that RT and RS are congruent? And we only know that because we were told that R is the vertex angle. And we have to know that the vertex angle is where the equal sides meet. So basically what we're going to do here is we're going to set this one equal to this one and then solve for x. We don't need x minus 1 in our equation. That's just kind of like, I guess, sort of a distractor. Also at the end, it does ask us to find st. So once we find x, we'll be able to plug that in. So I'm going to solve for x here, subtract x, add 5. So that's going to be 2x equals 12. So x is 6. So I found x, I solved for x. Now I just have to find these. So I just have to plug in x. So rs is x plus 7. So 6 plus 7, which is 13. Remember, when you find the length of them, you just plug it in. So then next is rt is 3 times 6 minus 5. So 3 times 6 is 18, minus 5 is 13. And then lastly, st is x minus 1. So 6 minus 1, which is 5. So that's the lengths of the sides of this triangle. Notice 2 of them are the same. They should be, because it's isosceles, right? So, so that's that example. Does anyone have a question so far about anything with isosceles triangles? Yeah. No. Okay, so our last example is about FGH, which is an equilateral triangle. So equilateral, all of them are the same, right? So we have FGH, all 3 are equal. So we have x plus 5, 3x minus 9, and 2x minus 2. So since it's equilateral, all 3 are the same. So for this one, you basically just choose any 2 of them and set them equal to each other. It doesn't matter which 2. You don't use all 3 of them. I've had kids try to do like this equals this equals this and have 2 equal signs. You definitely don't want that. You just choose any 2 of them. Doesn't matter. I'm just going to do these 2. I don't know, for no particular reason. X plus 5 equals 3x minus 9. And so again, we have to solve for x. So I'm going to add 9. Subtract x. So this is going to be 14 equals 2x. X is 7. Okay, so now it's it also asks us to find the measure of each side. So now we just have to take 7 and plug it into each of these. And that's it. So I'm going to zoom out a little so you can see what I'm writing. So let's see, FG is x plus 5. So 7 plus 5, which is 12. So I should be getting 12 for all 3 of these values now. GH is 3x minus 9, so 3 times 7 minus 9. So that's 21 minus 9, which is 12. And then FH is 2 times 7 minus 2. 2 times 7 is 14, minus 2 is 12. So you should get that all 3 are the same, or else something went wrong. Although I'm pretty sure actually on the practice that you guys are doing today on the quizzes, it was mostly just classifying, but then I added in some of these types of questions. So I think there's like 3 or 4 of them like this, but I just have you find x. I don't have you plug in. So you don't even have to worry about that. So that's it for this section. Hopefully you guys find it easy. I think you will. We're just spending today on it. We're not going to spend more than 1 day on this. And then on Monday, we're going to move on to the angles in a triangle.